So everyone okay sekarang? Ha?
Ada orang sesat ni.
Siapa? Ada orang
Wani tu siapa?
kawan korang guna email lain je kot. Apalah. Lagi ramai lagi bagus kan. Bazis ilmu ni.
Hari tu Hidayah.
Siapalah korang. Korang bagi kat awet-awet korang. Awet Ilham Patutlah Ilham comel hari ni kan.
Dia cakap sama ni. Wani.
Okay, dah. Kita nak start lesson kita. Okay. Nampak tak my slide saya tunjuk ni? Nampak tak? Okay. What we're gonna learn here today is intermolecular forces, and so basically today kita akan start belajar polarity and dipole moment lah of basic molecular shape. Later I'll go to intermolecular forces. Okay. So what is macam mana kita nak define polarity, or kita nak tahu dia polar ke tak polar ke, is all have to do with dipole moment. Okay. Macam dia butuh belakang. Okay, good. So dipole moment kita dapat from the charge and the distance between the charge. Okay, this is the charge. Okay, macam mana kita nak dapat the charge? Okay, so hari tu ingat tak kita belajar pasal electronegativity? Ingat tak? Kalau across the group, electronegativity increase ke decrease ke apa? Periodic table hari tu. Ingat tak? Mana korang semua pergi? Dah hilang ke semua orang? Okay. Hari tu, across the group, electronegativity increase, while down a group, electronegativity decrease. Ingat tak itu? Across the group, dia makin kecil, makin kuatlah dia nak tarik electrons. Kan? So, dipole moment is defined by kalilah dia nak is defined by the charge, or more cara nak faham is electronegativity difference. Okay, the higher the difference between the two atom, contohnya hydrogen dengan fluorine, the bigger the Q value. Sebab dia tengok it is the product of the charge from electronegativity, and R is the distance. So dipole moment most of the time akan governed by electronegativity difference. Dipaham kan? I buat tiga segi ni means difference, and X is the symbol for electronegativity. Boleh tak? Boleh tak?
Boleh.
Okay, good. Because kalau distance between two molecules most of the time at this scale is around the same. Okay. Dalam soalan, dalam buku, dia orang akan express dipole moment in dBs. Sometimes 0.1 ke ataupun 2.0 dBs ke. Okay. The higher the value of dipole moment, contohnya 2 dBi berbanding dengan 0.1 dBi, okay, this means that between the atoms, contohnya H and F, the electronegativity difference is higher. Yeah? Siapa nak masuk? Okay.
Aku tak.
Ni datang lambatlah dia masuk. Nanti saya bagi dia masuk. Okay. 0.1 dBi comparing to 2 dBi. So kalau you tengok, the higher the dBi values, maksudnya the higher the electronegativity difference. Okay. So this is the factors affecting polarity. Okay. So, okay. So factors affecting polarity. Okay. We have two things that we consider. Okay. The first thing, kita always tengok electronegativity dia. So the first tengok electronegativity and then tengok molecular geometry. Okay. Apa-apa je yang molekul dia bagi, first kita tengok between the two atoms, contohnya carbon and hydrogen, is it electronegative or not? The difference in electronegativity banyak mana? Okay. Can you write this? For polar. Okay. Untuk polar bonds, electronegativity difference is around 0.4 and above. More than 0.4, 0.6, 0.8, 2, 3, kita akan consider as polar bond. Boleh tak?
Boleh.
Okay. Another thing is, kalau dia bonded to element as such as nitrogen, oxygen, and group 17, it is most likely polar. Okay. Nitrogen, oxygen, and group 17 sampai around iodine lah macam tu. Okay. That's kita tengok electronegativity. Okay. Kita akan tengok form electronegativity, kita boleh decide the bond is polar ke tak. Okay. Because the first thing kita akan tengok electronegativity, kita akan tengok individual bonds. Okay. So, dia akan jadi non-polar kalau dia contohnya bonded with the same atom. Okay. Contohnya fluorine and fluorine. Okay. As you know, fluorine is the most electronegative atom. Okay, the most electronegative. Around 4 value this. Value electronegativity dia. Tapi, now dia bonded with also fluorine. So, their electronegativity will cancel out and this will be non-polar. Even though they're very electronegative. Okay. Sebab electronegativity, kalau you guys ingat, is the tendency of an atom to pull electron towards itself in a covalent bond. Okay. Berapa kuat dia nak tarik elektron yang dalam bonding ni, kan bonding kalau covalent dia orang share kan. Berapa kuat dia nak tarik to itself. Kalau dua-dua ni tarik dengan sama kuat, elektron tu you rasa nak pergi mana? Tak pergi mana-mana kan?
Tak gerak.
Ya, dia duduk je lah. Dua-dua tarik, ni dua-dua tarik sama, ni duduk. So, it is non-polar. Ataupun bond within two electropositive atom. Contohnya tadi carbon and hydrogen. So carbon the value is 2.55 while hydrogen is 2.2 electronegativity there. So don't worry about these values. It will be given to you. You tak perlu nak hafal these values. And kalau you tengok what's the electronegativity difference? Berapa? Berapa? Dan korang tekan calculator 2.55 tolak 2.2.
No.
Congak. Okay. So, kalau you tengok, the difference is lower than 0.4. So, it is non-polar. Plus, kalau you tengok, atoms that are around the 2 and around 2 value there is considered as electropositive. Electropositive. So, okay, CH ni is non-polar sebab both the atom are electropositive. So, plus dia punya electronegativity difference pun tak banyak. Okay. Second, kalaulah electronegativity dia tinggi, ibarat, okay, more than 0.4. Contohnya HCl. So, HCl. Hydrogen is 2.2 while chlorine is 3.16. Okay, this one tekan calculator tak apalah. 3.16 minus 2.2, you'll get around 0.96 electronegativity difference. So electronegativity difference is around 0.96. So tinggi from 0.4, kita can consider it as polar. Plus, kalau you tengok, it is any other electropositive yang bersambung dengan nitrogen, oxygen or group 17. So, chlorine is group 17. So, it is polar. Okay. So, lepas kita tentukan tu, okay, in a molecule, kalau dia bond dia semua non-polar, memang molekul tu macam mana pun dia akan jadi non-polar lah. Tapi, kalau the molecule tu, kita tengok bond dia is polar, tak semestinya the molecule is polar, even if the bond is polar. Because kita go second step, molecular geometry. Okay. So, kita tengok molecular geometry. We look on two things, symmetrical or non-symmetrical. Okay. If symmetrical is only kalau terminal atom all the same. Okay, symmetrical shape ni contohnya macam yang hari tu kita lukis tu, yang without lone pairs. So the basic shape, 5 basic shape tu, we have linear, trigonal, planar, tetrahedral, trigonal, bipyramidal, excuse me, octahedral. We have 5. Kalaulah kita tengok, even though it is polar, contohnya P dengan F, okay, P dengan F is a polar bond. Tapi kalau PF5, okay, so PF5, you get trigonal bipyramidal, okay, you will have a non-polar molecule sebab, okay, even though this one is polar, tapi the shape, when kita tengok molekul dia, it is symmetrical and it is also all the terminal atoms are the same. So, the polarity cancel out each other. So, don't worry, kita akan tengok lagi more example of this. And then, kalau non-symmetrical, dia sama ada bukan bukan linear, bukan trigonal planar, bukan tetrahedral ni, contohnya macam V-shape ke, seesaw ke, band ke, apa semua tu kan. Ataupun ingat tak assignment awak hari tu? CH2Cl2. Yes, dichloromethyl. You dapat tetrahedral kan?
Yes.
Tapi kalau ni dia cakap symmetrical. Tetrahedral is symmetrical. Yes, shape dia symmetrical. Tapi you tengok tak terminal atom dia? Terminal atom dia berlainan kan? Kita ada 2 hidrogen, 2 klorin. Semuanya tak sama. That's why kita dapat polar. Ada contoh is air. Air kalau you buat molecular structure dia, you akan dapat you akan dapat V shape. Sebab air ada dua lone pairs. Air juga is a polar molecule. Okay, we'll see few example and then we'll do few example together. So, contohnya HF. Okay, HF is a polar bond. Sebab kalau kita tengok, tadi kita tengok F is 4.0 while hydrogen is 2.2. So electronegativity difference dia berapa?
1.8.
Yes, 1.8. So it is very electronegative kan, the fluorine. So fluorine ni dia nak tarik those electron dekat diri dia. While hydrogen ni adalah semua dia punya elektron dah tertarik oleh fluorine. So this molecule is polar. And there's one way kita nak tulis, kita nak represent the polarity of a bond. Okay, so cara kita nak represent. Okay, first kita decide which of these two is more electropositive. Electropositive maksudnya nilai electronegativity value dia is rendah kan. So mana lagi satu yang kurang electronegative? H ke F? H ke F? Mana more electropositive? Which is H kan? H tadi saya cakap 2 while fluorine is 4. Okay, general rule is apa-apa je yang dengan fluorine is the other one, because fluorine is the most electronegative atom in the periodic table. So cara nak lukis dia, yes, nak represent, buat plus sign dekat hydrogen because it is the more electropositive. Then plus ni you sambung jadi arrow ke arah the more electronegative atom. So this denotes that the electron dekat hydrogen ni dah ditarik oleh F. This is the dipole moment punya arrow. Okay, and since the electron dia dah ditarik oleh F, walaupun dia orang ni share tau elektron, sebab dia orang ni bukan ionic, dia orang ni is covalent bonding. So even though they all share, banyak of the shared electron is dekat F. So what we'll have is a partial positive and partial negative charge. Kenapa ada partial ni? Okay, ingat tak? NaCl and ACl, Na have the full positive charge while negative is on chlorine. Because it is ionic. Okay, ionic bonding only when electronegativity difference is around 2.0 baru dia jadi ionic. Okay, but this one it is covalent bonding, so dia tak jadi fully positive. Kalau dia jadi fully positive, dia dah jadi ionic. Since it is covalent, technically they are still sharing the electron. We got partial positive charge. And cara nak represent the dipole moment is the positive charge on the hydrogen and all the electrons are ditarik oleh fluorine. So the arrow will be pointing at the direction of the fluorine. Okay, that's what it meant by cross arrow. The arrow is here, so this one is electropositive, while this is electronegative. It can be any other way. Always dekat buntut dia yang nampak macam cross ni, always dekat the more electropositive atom. let's see on CH4 methane. Okay, when considering this, if you guys tengok, carbon is 2.55 while hydrogen is 2.2. So the electronegativity difference is around 0.25. Kita dah discuss tadi, and it is very low. So the difference in electronegativity difference is negligible. So the molecule is non-polar. Macam mana dia nak jadi polar? Even kalau bond dia ni is non-polar. Kalau bond dia pun dah tak polar, it will not be polar. So it is a non-polar molecule. Okay, boleh. We only consider the molecular geometry kalau bond dia polar. Are you guys following the lesson?
Yeah.
Yes.
Okay, good. So, one general rule is kalau diatomic ni maksudnya dua atom. So, kalau atom tu berlainan and diorang have huge electronegativity difference, it will be polar. Kalau atom tu yang sama, walaupun dia adalah elektronegatif, it will not be polar. Macam saya cakap tadi, even though F is the most electronegative atoms, kalau F bonded to F, which is fluorine gas, sebabkan both are very electronegative, diorang are pulling the shared electrons at the same force. So, it will be non-polar, dia tak polar. Sebab the electron tu tak pergi mana pun. Semua are shared with the same amount. Okay. Sekarang kita akan tengok polyatomic atom. Okay, kita akan tengok carbon dioxide, carbon tetrachloride, chloromethane and ammonia. First, tengok carbon dioxide. So, carbon dioxide, lepas awak buat Lewis structure, awak akan dapat ni. Dan awak akan dapat the molecular geometry is linear. Sebab kita ada sigma bond and the pi bond. Okay. Carbon and oxygen. So, carbon has 2.55 and oxygen has 3.44. What's the electronegativity difference? Kira cepat. Kira. Yes, 0.89. So you rasa polar tak this? Bond ni polar tak? Kalau different dia is 0.89.
Yes.
Yes. Bagus. It is polar. So, yes. Kan? 0.89 kan? Saya cakap ni tadi, it will be polar if it is higher around 0.4. Tinggi daripada 0.4, 0.5 pun sometimes can consider as polar. So, tengok carbon and oxygen. Apa? Dia okey? Dia tanya apa tadi? Ada soalan ke? Okay.
Ana.
So, carbon and oxygen. Which one is the more electropositive? Mana yang nilai electronegativity lagi rendah? Carbon ke oxygen? Carbon. So, dia punya positive charge tu will be at carbon and the arrow will be pointing dekat oxygen. Sebab since oxygen is more electronegative, dia akan tarik the share electron dekat dia. So, kita dah tahu the bond is polar. Tapi, kenapa dia cakap CO2 is non-polar molecule walaupun bond dia is polar? Sebab we have one dipole moment going to the right and the other dipole moment going to the left. Okay, dipole moment kalau you perasan tadi, okay, dipole moment mu is the charge times the distance, and the charge is cakap a dot product. And you guys belajar physics dah tahu pasal vector quantity.
Dah.
Yes.
Vector quantity dia ada apa?
Ada arah.
Yes,
Thank you.
dia ada magnitude and arah kan?
Ah.
Magnitude and
Betul.
direction. So, kalau you rasa kalau carbon dia bonded dengan oksigen and also carbon bonded dengan oksigen, magnitude dia sama tak? The difference of electronegativity dia sama tak? Untuk this punya tu dengan this punya ni, sama tak difference electronegativity in this and difference electronegativity in this?
Lain.
Sama kan? Ini carbon dengan oksigen, this one also carbon and oksigen.
Okay.
So, since the magnitude sama, the only difference is direction. So, contohlah, sebagai contoh, this is not the actual dia punya nilai lah. Contohnya, the dipole moment of this is negative 0.89, while this is positive 0.89. Thus, kalau you ingat, vector dia ada direction, kan kita denote positive or negative just to represent dia punya direction kan. So, kalau one is negative and one is positive, the total dipole moment will be
0.
0. That's why we have no net dipole moment. Sebab dipole moment can cancel each other kalau dia orang are opposite direction. Okay, we will see the more hard to visualize punya atom, macam mana dia orang cancel. Okay, contohnya carbon tetrachloride. So, carbon and chlorine. So, carbon is 2.55. Don't worry, the values will be given to you. 3.16. What is the difference? Apa beza?
0.61.
Yes, very good. 0.61. So, polar ke tak ni? C ah.
Yes, polar.
So, positive charge tu dekat C ke Cl?
Dekat
C.
Dekat C kan? More
Because
positive.
less.
Yes, more positive. Okay, tengok the value. Cl is more electronegative. Cara nak buat arrow tu, dekat more electropositive, nilai yang lagi rendah ke nilai yang lagi tinggi. Positif ke arah tu. So, kalau you tengok carbon tetrachloride ni semua ada. Kalau you cakap dipole moment, you kena tulis untuk semua. So, even though you tengok actually macam boleh ke dia orang cancel each other ni? Kenapa dia dapat non-polar? Okay, sebab kalau you ingat, tetrahedral is a symmetrical shape. Okay, I'll tunjuk my model to see why it is symmetrical. Okay, ada question ke? Okay, so where's my model? Okay, you guys nampak here? Here. So, why I say it is symmetrical? Kalau you tengok, anywhere I pusing, it will look still the same molecule.
Yes.
Yes.
Yes. So, if we have all of the dipole moment pointing at one dekat atas, satu dekat awak, satu dekat kiri, satu lagi dekat belah kanan ni. if everything are pointing that, actually kalau kita kira, korang belajar fizik tu yang kena kira vektor tu, ada cos, ada sin semua tu, you kena angle semua tu. Bila kita kira dengan angle semua ni, it will cancel out each other. That's why basic shape semua akan cancel each other. So kita ada linear ke, trigonal planar ke, tetrahedral ke, tetrahedral ke, trigonal planar ke, octahedral ke, any of those basic shape, trigonal bipyramidal ke, it will cancel the dipole moment. But only if all the terminal atoms are the same. Macam hari tu CHCl2, kita ada 2H, ada 2Cl. It is polar sebab kita only have 2Cl and tak ada, we have no more Cl untuk cancel sebab carbon and hydrogen are non-polar. Okay, their only difference is around 0.35. So it is a non-polar bond. So you cannot cancel the polar bond of carbon and chlorine. So I'll go back to my slide. Okay, we'll go to chloromethane. Okay, same geometry, it is tetrahedral, tapi why this time kita dapat polar molecule? Sebab if you look closely, we have two different type of bonds. Kita ada C dengan H and C dengan
Cl.
And we know C and Cl is polar. C and CH, the difference is around 0.35. It is non-polar. So, kita draw the shape. Because kalau non-polar, you tak perlulah nak buat arrow. Sebab dia tak ada dipole moment pun. Tak ada dipole moment. So, there's no dipole moment. Tapi, kalau dia polar, dia adalah dipole moment. So, CCl, macam tadi, positive or more electropositive ke electronegative charge atom. Tengok, mana je yang carbon and chlorine, ada satu je. So, draw the same. Positif dekat carbon. So, you tengok. Alamak, ada tak nak cancel? Tak ada kan?
Tak ada.
So, it cannot cancel. So, it has a net dipole moment. Dipole moment dia bukan zero. So, that's why CH3Cl is a polar molecule. Even though dia adalah tetrahedral. We look at the last one. Ammonia. Ammonia is also tetrahedral. Tapi kalau you tengok balik, molecular shape dia is trigonal pyramidal. Kan? Dia akan bentuk piramid tiga segi ni. So, N and H. When N is 3.04 while H is 2.2, electronegativity difference dia berapa? Berapa?
0.84.
0.86. Ya, aku berdekat ni.
8 ke 7? No.
4.
Tak ada siapa nak tekan kalkulator Saya
Dekat
ke?
ni.
8.4.
8.4. 8.4
8.4.
Sekejap.
0.84.
Okay.
Congek tu.
8, 4.
4.
Okay. So, since it is quite high, so it is polar kan? Okay. Macam mana arrow dia? Positif dekat mana?
From H.
Yes. From H ke nitrogen. So, when you dah lukis, so it's from H ke nitrogen, from H ke nitrogen. So, the same. So, kalau you tengok balik, we have a net dipole moment ke atas kan. Kalau you tengok ni, macam all the dekat piramid tu are pointing up. Semua dia punya dipole moment are pointing up. Sebab lone pairs, kita bayangkan macam dia tak ada pun. Kita bayangkan dia sebagai, nampak tak? Dan nampak pun macam hantu, so kita bayangkan lah dia macam dia tak ada. So, dipole moment cannot cancel each other, and H3 is a polar molecule. Okay. Do you have any question so far? Ada question tak? Question, soalan, pertanyaan? Ada tak?
Ada.
Okay. So now, siapa sini yang guna laptop, siapa guna phone?
Ada.
Okay. Good. Siapa yang guna laptop, can you give this link untuk siapa yang guna kat phone? So, I'm gonna start a quiz. I can start quiz. InsyaAllah. Don't worry lah, 4 question only.
InsyaAllah.
4 question. I'll copy the link. Okay. Tengok dekat Google. So, this is the link. Can you...
Okay, guys.
Yes, kita nak buat quiz. It only 4 questions, so don't worry. Okay, molecule polarity. So, tolong share dekat WhatsApp ke siapa yang ada. Yes, Adam. Kenapa agak tangan Adam? You okay? Kalau tak ada laptop, can you try masuk dekat browser you dekat phone? Tapi kalau siapa yang betul-betul tak boleh, tak apalah. Kawan, kalau boleh, everyone masuk and try.
Kita ni saya tak tahu saya.
Laju korang masuk. Bagus. So this is only 4 question. Kita basically, you guys can determine which molecule are polar, and then what is dipole moment. Ingat balik, dipole moment is mu equal to Q times R. Q is the charge, and then times the distance between the charge. Okay? So dah 8 participants. Siapa yang lain boleh tak masuk?
Tadi apa? Mu equal to?
Q times R. So I'll present balik tadi. Window. Okay, look at this. Nampak tak? So, dipole moment is charge, the product of the charge times the distance between the charge. That is mu equal. That is dipole moment. Apa yang kita dah buat arrow with the plus. Oh, tadi semua tu. So, we have 12 participants. Everyone here ke? Or ada yang siapa tak masuk ni?
Masuk.
Okay. 3 more people. Comel lah korang boleh letak emoji kat nama korang.
Saya profile ni.
Oh, I see.
Profile ni.
Saya pun tak tahu macam mana buat. I think
Okay, kau.
15 people, 16 people. So the other two tu, kalau tak boleh masuk, let me know lah. Ke boleh? Tak boleh. Because I'm gonna start the quiz. So get ready, and nanti kita akan discuss what we find the most difficult. I'll start the quiz. So, dipole moment. What is dipole moment?
Sekejap. Sekarang waiting for others to finish. So,
Everyone okay ke tu? Ada yang tak sempat jawab? Afiq.
Masa je ke?
Yes. Ada masa untuk everything. Don't worry.
Kalau buat bawah ni, so apa?
Don't worry.
siapa yang jawab A tu? Tak payah lah, tak payah tahu.
Tak perlu tahu. Because nanti korang dalam exam pun ada masa kan. Diorang taklah pergi exam suka hati je korang nak hantar bila kan. So now, kita go to the next question. Which of the following is the correct representation of HF? Mana satu the more electropositive, mana satu the more electronegative?
Electronegative H tu.
H, electronegative. Mana satu electronegative?
Salah tadi daripada
H is electropositive.
nak hidup.
Nah ya, Roy duk. Okay. Afiq tak siapa boleh potong ni. Okay. Next questions. I cannot remember what question it is. Okay, mana satu polar. Ada dua jawapan. Which of the two? Ada dua molekul yang polar and dua tak polar. So ingat yang mana boleh cancel, mana tak boleh cancel.
Kalau cancer tu dia polar kan?
Kalau dia boleh cancel, maksudnya dia dah jadi non-polar sebab dia cancel each other. And I'm just saying that beryllium is 1.57 and hydrogen is 2.2.
Dah sebab tak submit.
Okay,
Oh, Hamzah.
so I see like a lot of people take hydrogen, beryllium H2 kan. Beryllium, kalau you tengok you punya periodic table, always refer to periodic table, is actually dekat group 2. So the electronegativity difference between hydrogen and beryllium tak banyak beza pun. Hydrogen is 2.2 while beryllium is 1.57. Tak banyak beza sangat and both are group 1. So it is non-polar. Plus kalau polar pun it is symmetrical. It can cancel each other. Okay. And then the last question.
Polar.
Which of these molecules are polar? Kita ada dua je. Choose one.
Dia nak cancel kan?
This one is a very easy question. Sama je dengan you punya assignment. Satu, all of the terminal atoms are the same. While the other one, satu tak sama. So, siapa jawab satu tu? Okay. Good job. Hamzah. Jauh dia tinggal korang. Hamzah dengan Adam.
Alhamdulillah.
Hai.
Tidak.
Bagus. Okay. Bagus lah. Okay. One thing okay. Kita go back to the window. Nampak my PowerPoint?
Nampak.
Okay, nanti you guys, I think SEM 2 kot, you guys akan belajar benda yang sama dalam physics. Dia akan electricity kot, pasal charge. It is the same thing as dipole moment. Dipole moment is Q times R. Q ni is the dot product of the charge. Contohnya between hydrogen and fluorine. Ya Allah. Okay. So hydrogen and fluorine. So it's the dot product between these two, and then darab the distance between them. That is the definition of dipole moment. Dipole moment is a product of the charge and then times by R the distance between the charge. Okay. And then tadi semua tu kita dah cerita pasal kalau it is symmetrical, it will not have contohnya tadi beryllium. Allah, ni putih pula dah. Okay. Dia putih lagi. Okay. Beryllium and hydrogen. Even though beryllium and hydrogen are polar, tapi if the dipole moment cancel out each other, will they still be polar? This one is negative, this one is positive. So you get non-polar molecule. Can we buat satu kita buat contoh boleh tak? So this ibarat macam dalam exam, dia bagi je molekul tu, dia tak bagi semua dia punya molecular geometry semua. Sekejap, you guys nampak kan my PowerPoint ni yang kosong ni? Nampak ke tak? Okay, good. Okay, so guys, for an example, dia bagi aluminium tribromate and say determine tulisan tu buruk ni, its polarity. Okay, dia minta determine its polarity. What is the very first step you guys have to do? First step, kita nak tahu polarity, kita tahu from molecular shape. So nak dapat molecular shape, kita dapat dari mana? Macam mana nak dapat molecular shape? Lepas tu kita lukis molecular shape tu. First, before molecular shape kita lukis, kita buat apa?
Structure.
Yes. Nak buat Lewis structure, kena kira apa dulu? Valence electron. Yes. So,
Yes.
aluminium group berapa?
Aluminium group
13. So dia ada berapa valence electron?
3.
3. Bromine group berapa? So the total valence electron?
Valence electron is bromine ada 2. Berapa tu?
Kalau satu 24.
Yes.
Pandai.
Bagus. So then kita akan draw the Lewis structure.
Yeah.
And we know
Draw.
that aluminium is the more electropositive. So kita letak bromine dekat keliling ni. Tak kisah awak buat macam mana pun. And then the next step is kita complete the octet.
Okay.
So berapa dah elektron yang kita dah use? Kita punya 18 as lone pairs dan kita ada 6 bonding pairs. So 18 tambah 6 berapa?
24.
Yes. So tapi aluminium belum lagi octet. Boleh ke?
Ya, boleh.
Betul.
Ingat tak?
Complete octet. Complete octet.
Yes, it is incomplete octet sebab hydrogen
Group
and
dalam group 17 tak boleh.
yes, group 17 cannot buat double bond. So it is incomplete octet.
Complete octet.
Right. So, nak tahu molecular geometry dia, molecular shape, kita tengok central atom only and berapa pair yang dia ada. So, 1, 2, 3.
3.
So, kalau 3 dia kita dapat apa?
Trigonal planar.
Yes.
Trigonal planar.
Trigonal planar. So, cara nak lukis aluminium dekat tengah, kita lukis dulu the central atom. And then buat Y. And then kita lukis bromine, bromine, and bromine. So, kita dah tahu dia punya shape. And then kita tengok aluminium and bromine. So, aluminium, dia punya electronegativity is 1.61, while bromine is 2.96. Kira berapa electronegativity difference dia?
1.35. 1.35.
1.35.
Yes. So it's 1.35. 35. So, it is polar ke tak?
Yes.
So, the bond is polar. Mana satu yang electropositive? Aluminium ke bromine?
Aluminium. Because less.
Yes. So, the positive going towards bromine. Just bromine the more electronegative. Like that. Like that. So, tapi, you guys tengok, this is one of the basic shape. We will get non-polar molecule. Kita akan dapat non-polar molecule sebab we have zero net dipole moment.
Dipole moment.
Okay. Walaupun you nampak, alamak, ini ke bawah, ini satu ke kiri atas, satu ke kanan. Kalau you ingat, kita kira vektor hari tu, kita kalau dalam physics, you kena buat table kan, ada 2 table tu. Satu yang cos and then ada sin. So kalau awak kira those angle 120 tu, awak kira the total you will get 0. Akan dapat 0. So tapi dalam chemistry awak tak perlulah kira, nanti mati awak. So apa yang awak perlu buat, awak yang perlu hafal basic shape. Kita ada 2 pair sampai 6 pair kan?
Ya.
Kalau all terminal atom dia, terminal atom which is yang keliling dia, all terminal atom are the same. Kalau terminal atom, all the terminal atom are the same, we will get non-polar sebab we have zero net dipole moment. The dipole moment cancel each other. It's only kalau terminal atom semua the same. Sebab tu hari tu kita dapat carbon, hydrogen, chlorine. Even though it is a basic shape, dia adalah tetrahedral, tapi the terminal atom tak sama. We have chlorine. Hydrogen and carbon is non-polar. So tak ada siapa nak cancelkan this two. So we have a net dipole moment. Okay. Do you have any questions so far?
Nope.
Everything good?
Fokus sakit.
Ya bagus korang ni. So next week kita akan start masuk intermolecular forces. Kita akan belajar pasal, kalau you guys tengok, this presenting my, nampak my camera?
Nampak.
So kita akan belajar the intermolecular forces. So hari tu kita belajar ionic bonding, covalent bonding. It is intramolecular, maksudnya dalam molekul. Ibarat this benang. Nanti kita akan belajar inter, which is between molecules. So bayangkan sebagai velcro ni, and kita akan tengok what effect does intermolecular have on compound. Contohnya air. Kenapa when kita boil, kita akan break which bond? Kita akan break dia punya covalent bond ke ataupun intermolecular forces dia. So itu kita akan belajar on next week punya kelas. Do you have any questions so far? Tak ada kan? Ada. Okay, kita baca pasal dipole moment. Any question? Any question? So since tak ada. So since tak ada question, siapa yang tak ada dalam kelas kita sekarang?
Kau tak ada kan?
Siapa? Anissa.
Anissa lagi. Anissa.
Amisha.
Kan aku tak ada kan? Tak ada.
Tak ada.
Ada kan? Dia tak sihat. Dia tak masuk kelas hari ni.
Okay. Tak apa. So that's it for our class for today, and see you guys next week. Continue buat chapter 7 punya tutorial. Chapter 6 saya dah upload kan soalan, jawapan. Check you punya jawapan. So chapter 7 start buat sekarang, and then kita akan maybe bincang next week. Sampai 7.2 lah. 7.2. Okay, thank you, and I'll see you guys next week.
Thank you.